Picture a dense tropical canopy at night. You hear rustling in the palm fronds 30 feet above you. Normally, you'd expect to see a bird, a bat, or maybe a monkey looking down. Instead, peering out from the darkness is a 9-pound, heavily armored arthropod clinging to the tree trunk. To understand the actual scale of this creature, look at its legs compared to an adult human hand. The span from claw to claw can reach 3 full feet. We are conditioned to think crustaceans belong safely at the bottom of the ocean. Seeing one the size of a dog navigating the upper canopy of a jungle triggers a search for how such a biological anomaly exists. For centuries, sailors and locals shared rumors about giant crabs that would creep into camps at night, steal shiny tools, attack small pets, and drag food away into the underbrush. Researchers often treat historical folklore with skepticism, but field observations confirm these creatures are highly aggressive, nocturnal ambush predators. Their primary weapons are designed to shred hard organic material. They easily rip apart the fibrous husk of a fallen coconut and crack open the solid inner shell to reach the meat. Proving these behaviors are documented fact focuses the biological question on the mechanics of the transition, how a marine scavenger developed the specific tools to survive and hunt on dry land. The first obstacle to living on land is gravity. Arthropods rely entirely on an exoskeleton rather than an internal skeletal structure, meaning terrestrial crabs usually stay small to avoid collapsing under their own weight. To reach a weight of 9 pounds, the coconut crab developed an incredibly dense, mineralized shell that acts like a walking vault. You can trace the origins of this armor by looking at their closest living relative. The coconut crab evolved from a vulnerable marine scavenger that had to use discarded snail shells to protect its soft abdomen. Over millions of years, the ancestors of the coconut crab grew too massive to fit inside any natural shell found on the beach, eventually forcing them to calcify their own permanent armor plates. Leaving behind the safety of a borrowed shell allowed them to pack on immense muscle mass, using sheer physical bulk to dominate the island floor. But physical size wasn't the only hurdle. Crabs breathe through gills, meaning a creature this large should rapidly asphyxiate once exposed to dry air. To solve this, their anatomy developed a specialized spongy tissue mass known as a branchiostegal lung. This hybrid organ acts as an evolutionary bridge, absorbing oxygen directly from the thick, humid air of the tropical jungle. The adaptation is so complete that the crustacean has entirely lost its ability to breathe underwater. If you fully submerge an adult coconut crab in the ocean, it will drown. This chart shows a coconut crab's gripping power. Researchers measured the maximum pinch at 3,000 newtons. If we compare that to the bite force of a leopard, black bear, or lion, the crustacean's crushing power is higher than all of them. Solving the physical hurdles of gravity and respiration allowed the crab to become the largest invertebrate to ever walk the earth, a dominant scavenger capable of outmuscling almost anything it encounters on the forest floor. Yet for all that armored bulk, their greatest flaw lies right at the water's edge. During the breeding season, heavy, air-breathing females must leave the trees and navigate the crashing surf to release their fertilized eggs, risking drowning with every wave. Once in the water, the offspring hatch into a defenseless larval stage, drifting in the oceanic currents as nearly invisible specks of translucent zooplankton. They spend weeks being hunted by fish and swept by tides. The 9-pound adult we eventually see clinging to a palm tree is the rare survivor of a low-odds numbers game. Even if they survive the ocean and drag themselves onto land, the growth process is slow. It takes up to 4 decades for a coconut crab to reach its maximum adult proportions. That extended timeline means a single instance of habitat destruction or overhunting can wipe out generations of these animals before they ever have a chance to replace their numbers. When you trace their life cycle from a microscopic speck in the reef to a heavy armored giant in the canopy, you realize they are a highly specialized branch of life that has evolved to thrive in a narrow ecological niche. Encountering a coconut crab in the dark might trigger a primal sense of fear, but losing the specific island habitats that allow such a massive terrestrial crustacean to exist would be a much greater tragedy.